This is for Remington and Megan. We are doing rhombus and right? Remington and Megan and Ethan. Sorry, I didn't forget you, Ethan. You three. Here is we got to do rhombus and square today. We're only going to get about halfway through the notes, so that you don't have homework this weekend. This nice long 4-day weekend. We'll finish this notes on Monday, but before we get to rhombus and square and fill these two boxes in, we have a treat for you, and it is a treat. They're so excited. Brian drew this. Brian, Remington, this is for you. It's a self-portrait of Remington, not a self-portrait. A portrait of Remington drawn by Brian. So there you go. There's your treat.
It's an auto, but
You have to say his name like how much.
I actually just found a picture.
Oh, he just found a picture of you. It's an exact picture.
Gave
What?
me some pictures.
What?
His mom gave me some pictures because we're close.
Okay, sure. Anyway, so that's your little treat for the day. All right.
That's why I was at your house last night.
Rhombus and square.
No.
Ready for rhombus and square? You got this paper? We're gonna fill these two boxes in. We'll do like the first two examples and then we'll be done. Okay? Rhombus. Do you know what a rhombus is? A rhombus. A rhombus is a rhombus, right? But what is a rhombus?
Five.
No, they all have 4 sides. What is a rhombus?
Is it like
Is
a
it
trapezoid?
the slanted one?
It's a slanted one.
It's a slanted square.
It is a slanted square. That's exactly what it is.
I'm so smart.
It is a
Oh,
slanted
no.
square.
It's a diamond. That's what it is.
Kinda, yeah. A rhombus is a diamond, exactly. Now, it is not, it's a little bit different from a parallelogram in the fact that all 4 sides are the same length. So it is literally a tilted square. A parallelogram is like a tilted rectangle, right? But a rhombus is a tilted square where all 4 sides are the same. Got it?
Holy cow.
But the length inside.
No. The diagonals? Yes, we'll get to that. Okay, so a rhombus. A rhombus is a parallelogram. We have that star there, which means all of these things apply. So here we go. The opposite sides are parallel in a rhombus, yeah? Opposite ones are parallel. The opposite sides are congruent. Now, we're going to write this down here in just a second. Not only are the opposite sides congruent, but all 4 of them are congruent, yeah? Okay, so he's better than a parallelogram in that sense. The opposite angles are congruent. Still true? Opposite angles congruent for a rhombus? These match and these match? Yeah? And the last couple ones, consecutive angles are supplementary. That means this guy and this guy add up to be 180 and all the way around. And then the other one is that the diagonals bisect each other. Do they still cut each other in half? Brian just said, though, this one is longer than this one, yeah? Is that still true? Okay, so let's talk about some things. In addition to being a parallelogram, we have one thing better about a rhombus that a parallelogram doesn't have. What's true about the sides of a rhombus?
Equal.
All 4 of them. All 4 sides are congruent. It is a tilted square. All 4 sides are congruent. Okay? All right, now let's talk about the diagonals. These guys here. There is something, I'm going to put a star by this one because people forget this one a lot. Okay? What's true about the diagonals? We know that they bisect each other. We know that they're not the same length. But what else is true about the diagonals? Something special.
They're different angles.
What's different angles?
The diagonals.
What do you mean?
The angles. Where's it?
Opposite.
Very quickly, I need help answering a text.
No.
Yes.
Just wait.
Oh, angles.
The
Opposite.
diagonals.
I don't. Ow.
The what? You're doing something.
The opposite angles.
What you talking about?
That one and that one.
This angle matches this one?
Yeah.
Yeah, we already know that. though.
Yeah.
Yeah.
So
That's-
what do you?
That's from up
What's
here.
the
Opposite
question?
angles are congruent. Whoop. Diagonals. What's true about the diagonals?
Oh.
They're not the same length. This is not the same length as whoop.
Well, I just.
This is not the same length as this one. But what's true about the diagonals?
Bisect.
We already know they bisect.
I don't know.
What's true about the diagonals? Look at where they come together. There's something real fancy right here that happens. Ah, they make 90 degrees when they come together. Okay, let's look back at a rectangle. Here's my rectangle. Is this 90 degrees and this 90 degrees? No. In our parallelogram, is this 90 degrees and this 90 degrees? No, but for a rhombus, it makes a 90 degree angle. What's that called? The diagonals are perpendicular. And perpendicular, the symbol for perpendicular is an upside down T. Did you know that? So the diagonals are perpendicular. They make 90-degree angles when they come together, which is not true in a rectangle, and it's not true in a regular old parallelogram. Okay? Now, let's talk about the angles with the diagonals. Like this angle right here, this angle right here, this angle right here, this angle right here. We know that the opposite ones are the same, but what's the diagonal doing to the angle?
No, bisect.
It splits it into two equal pieces. So like this guy will be the same as this one. Let me go to a rectangle. Is that true in a rectangle? Is this angle the same as this one for a rectangle?
No.
No. Is it true in a parallelogram?
No.
Is this guy the same as this one? No, but in a rhombus, it does separate this into two equal pieces, right? So I'm going to guess that on your homework assignment, like they'll say like this is 4x minus 6 and this is 2x plus 3. And they'll say solve for x. If this is a rhombus, those two will be equal to each other, right? Okay? So the diagonals bisect the angles, which means it splits it in half. I'm going to put a star by that one because that's another one that people forget all the time. Okay? Good? All right. I will give you a second.
my advice now?
What?
Can you give me my advice now?
What?
I said, I need money for a very important cause. Do you Venmo? And he said, no, unless you tell me what the cause is.
So tell him what the cause is.
Because then he's going to say no.
What is the cause?
You're not going to give me any money until that's you.
3 seconds.
What
Say
is
that
the
we're-
cause?
Say that we're spending it tomorrow.
My nails.
Say that we're spending it tomorrow.
All right. Go draw your square.
How about get a job?
I have a job.
Who is this that we're asking money for?
My dad.
Oh.
Ooh. You know what? I'll use something against him.
Oh,
He
boy.
spent
Maybe
$65.
I'll get something my mom has money.
All right. Square. Draw your square. Okay?
Wrong with
A
that.
square is a parallelogram. That's a star. That means all of these things already apply. Yeah? The opposite sides are parallel. The opposite sides are congruent. The opposite angles are congruent. Consecutive angles are supplementary and the diagonals bisect each other. Great. In a square, what else is true about the sides of a square?
Always.
That's not true in a parallelogram.
Always.
All four sides are congruent in a square. 1, 2, 3, 4. Okay? What's true about the angles of a square?
Bisect.
All equal.
90 degrees.
All angles are 90 degrees. Okay, that's true about a square. What else is true about the angles? Let's talk specifically about the diagonals.
Bisect.
The what?
Bisect.
The diagonals bisect the angles. Now, if all the angles are 90 and the diagonals are bisecting them, well, what's happening?
What?
Like, what are each one of these angles going to be for a square? They will be 45s always, right?
Yeah.
Is that true for a rhombus? Will they both be 45 always?
No.
No, because they're not 90 to begin with. But if it's 90 to begin with and we're separating it in half, we have some 45-degree angles there. So the diagonals are bisecting the angles. Great. What else do we know about the diagonals?
Equal.
They're equal. The diagonals are congruent in length. Okay? And what else is true about the diagonals? Like how they come together.
Bisect the.
They bisect each other. We already know that from being parallelograms. What else do we know?
Bisect the.
We already know they bisect the angles. We wrote that down just now. Diagonals bisect the angles. What else is true about the diagonals?
No.
They are what?
That's not what we're talking about.
What's true about where the diagonals come together?
It's the exact center.
It is. You're right.
90 degrees.
90 degrees. That's what I want. The diagonals are perpendicular. And I draw an upside down T for perpendicular. Diagonals are perpendicular. Okay. All right. At the end of the chapter, you guys are going to get a blank one of these. And you're going to have to fill all of this junk in. Woo! Does that seem overwhelming at this point?
Yes.
All right. Then let me
A lot
show
of
you.
it's the same.
Then let me show you how to cheat. Are you ready? Did you know that a square is also a rectangle? But a rectangle is not a square. Did you know that?
Yeah.
Okay? In order to be a rectangle, it has to be a parallelogram. All angles are 90 and the diagonals are congruent. That's the only requirements for a rectangle. Is a square a parallelogram with all right angles and the diagonals are congruent? So a square is a rectangle. But a rectangle is not necessarily a square because all four sides aren't congruent. That's what makes a rectangle not a square. So a square is a rectangle, but a rectangle is not a square. Make sense? Okay, now, a square is also a rhombus, but a rhombus is not a square. In order to be a rhombus, all four sides have to be congruent, which a square is. The diagonals have to be perpendicular. What is happening? Hold on. Un momento, por favor. Okay, in order to be a rhombus, all four sides have to be congruent. Does a square have all four sides congruent? Does a square have diagonals that are perpendicular? Does a square have diagonals that bisect the angles? That means a square is a rhombus. But a rhombus is not a square. How's come? Why is a rhombus not fit into this category?
Because of the angles.
The angles aren't 90 degrees, right? So a square is a rectangle, but a rectangle is not a square. A square is a rhombus, but a rhombus is not a square. Not all rhombuses are squares, yeah? Now here's the deal. Here's how you can remember these things. Ready? Let me erase some stuff. Okay, in a square, all four sides are congruent. All four sides are congruent. All angles are 90 degrees. All angles are 90 degrees. The diagonals bisect the angles. The diagonals bisect the angles. The diagonals are congruent. The diagonals are congruent. The diagonals are perpendicular. The diagonals are perpendicular. All five of these things come from these two and these three combined. Because a square is a combination of a rhombus and a rectangle. Did you know that?
Yeah.
The square is a perfect combination of a rectangle and a rhombus. So if you know these three and you know these two, you can cheat and just lump them together here. Got it? Yeah, that's all. And that can help you figure out, because if you know, like, maybe these five.
Is Singleton in there?
Yes, he is.
Kurt needs to see him, please.
Okay. If you can remember them for a square, then maybe you can figure out what these are. If you're, like, you can use that to remember which ones you're missing, right? Okay. These three and these two come together to make these five. Yeah? And I've just made a mess of my page, but it's fine. Whatever. Okay, go to the notes. Go to the notes. We'll do the first two and then we'll stop. Rhombus and square. We are on example 1. Anything that's up above here where it talks about these are the ones that are already on our grid. The diagonals are perpendicular. The diagonals bisect the opposite angles. We already know that. We wrote those down. Okay, let's do example 1. It says LM. Is LM a side or an angle? A side. LM is this guy. And that is 2x minus 9. So we're talking about like the length of the side. Okay. KN is another side. He has this bottom side right here. And that is x plus 15. And they want us to solve for x. And that's all they give me. And this is a rhombus. What are we going to do? Set them equal. 2x minus 9 equals x plus 15. And I'm going to subtract x. I'm going to add the 9. And x is 24. You're so smart. You are such a genius. Good?
Yeah.
Not so bad. All right, example 2. Now we're doing angles. Okay, now we're doing angles. All right, this was a little bit trickier. 75 degrees. LMN, angle, LMN. This whole top angle right here is 75. 75 degrees. Okay? They want us to find KNP. KNP. This angle, which is like half of this bottom one right here. That's what we don't know. We know the top one, the whole thing is 75. Let's figure out how we can solve this. Whoop.
I'm ripping that guy out.
That's my start cleaning up, 4th period. Okay. 75 degrees up top. How do I figure out what this angle is down below here? There's a couple different ways you could do it. What would you like to do? As soon as we're done with this one, we're done.
Well,
What would you like to do?
they're the same size.
What?
So,
What's the same size?
Rhombus.
What?
you obviously take.
Divide 75 by 2?
TKN.
Yeah.
Half of 75 and then set it equal to that.
Yeah.
Okay, 75 divided by 2 is 37 and a half. So this guy will be 37.5 and this guy will be 37.5. So is this 37.5 and this 37.5? Like we're trying to find this one right here.
This ain't no square.
Is that 37.5? Because then they would all be 37.5s, right? But I don't think that's true because this angle is not the same as that one, right?
Can't be done.
I don't think that's gonna work. What else would you like to do?
Need more information.
No, you don't. You got enough.
Well,
Don't they have to?
we know
equal
that the
180?
K has 37.
Doesn't the one
Okay,
line?
all right.
So
So he
then-
says this is 37.5 and this is 37.5. I'll buy it.
Now, we need that one plus another
What
one,
the best words?
and then we can divide, or, subtract the one.
Okay, let's look at this triangle right here,
What's the middle one?
right? Let's look at this triangle.
Yeah.
We're trying to find this angle. Do we know what the middle one is?
90 degrees.
Isn't it 90 degrees?
Yeah.
Hey, all right. 90 plus 37.5 is 127.5 when we're subtracting from 180. And that is what? 52.5. Check it.
Divide that by 2.
What?
63.75.
What are you talking about? No, wrong. Try again.
Matthew.
I already gave you the answer.
Oh,
My brain works faster than a calculator.
52.5.
Oh man, woo! We've been sitting here a long time. All right, 52.5. Now, that is the answer. Got it? Do you see how we arrived at that conclusion?
Yeah.
Now, let me show you a different way. And if your brain works this way, it might be faster for you. I don't care. Let's do this. This whole angle is 75, yeah? This is a parallelogram. So doesn't this angle and this angle add up to be 180? What's 180 minus 75?
Well, duh. That would have been.
You can do that in your head.
105.
105. So that means this whole angle is 105. So how do I find out just this part? Divided by 2. That is 52.5. You see it? So we could arrive at that conclusion that way as well. It all should fit together. So however you want to go about doing it is totally fine. Okay? Good? Beautiful. All right, that is all. We'll stop for the day. Yeah, because we've got like 3 minutes left. Okay, goodbye.
Bye, Ren.
Ruh, ruh, ruh.
This is the difference between my
like
mom
Benjamin.
and my dad.